Now we examine properties of chords. Chord property 1. Chords are congruent if and only if the intercepted arcs are congruent. What that looks like is if this chord from here to here is the same length as this chord from here to here, then it has to be cutting off the same amount of circle. So this arc has to be congruent to this arc because this length will be cutting off the same amount because this length is the same or congruent. Let's see how we can apply that. Find all the minor arc measures in circle C. So first thing I notice is here has a congruent slash on this chord to this chord. Therefore, I know right away this arc is congruent to this arc. So if this arc says 147 degrees, this arc will also be 147 degrees. Then I just have one arc remaining, minor arc MN. Well, remember all the way around the circle's 360, so do 360 and take away the other two arcs that make up the remainder of the circle, and you have the last remaining arc. Not too bad. Chord property number 2. Chords are congruent if and only if they are equidistant from the center of the circle. So let's start by drawing what we think is the center of the circle. Then let's draw a chord and let's measure it and make sure we draw a chord the exact same length somewhere else in the circle. So you can see I drew a chord that is approximately 30 centimeters on my ruler. Let's go find another place on the circle, and you know what? Not even in the same direction. Let's make the chord go in another direction, and let's draw that chord. So you'll notice how they look like they're about the same distance from the center. First of all, let's mark that they're congruent chords. Now I pulled out my ruler to find the distance, but I want it to be the distance is perpendicular to a segment. So I have to use my ruler not just as a measuring device, but also to show that I'm making a right angle. So I lined it up so that the edge of the ruler is touching the chord and the other edge is touching the point. Then when I connect from the center to the chord, it's going to be perpendicular. So let me move this out of the way to make this a little bit easier to connect it. And that distance is what I want to make sure I have on the other side. Now, it's not 10 centimeters because I needed to use the edge of my ruler, so let's remember that. And there we go. Notice this is the same distance, also 10 centimeters. Let me move this out of the way. Well, then of course the little edge of my ruler. So equidistant. This distance, same as this distance. Same, same distance. Notice the other thing that happened when I drew that segment to the chord, the segment that came from the center of the circle. Do you see it yet? I'm not going to point it out just yet. Maybe you'll think of it by the time we get to chord property number 3. Let's take a look at an example that uses this property. If ST equals 60, so from here to here is 60, I'll mark it in the middle, and VU equals 60, so from V to U, same thing, then find the value of X. Well, as soon as I know these chords are congruent, I know that I can say these distances are congruent. The distance from the center to the chord. That distance is the same as that distance. So what means the same? Equals. So segment 5x squared that's labeled 5x squared is equal to the segment labeled 45. And now I can solve that equation. Let's get that 5 out of there by dividing. And then let's take the square root. Remember when we take the square root to say plus or minus. X could be positive 3 or X could be negative 3. Now if I plug -3 in here, remember -3 times -3 makes 9, just like 3 times 3 does. So it's both of those answers. Last property. Oh yeah, I just remembered. I wanted to ask you one more thing about what you notice in this picture. So you see these segments coming out from the center to hit these two chords that are congruent. Well, not only do they make a right angle to these two chords, but do you see where they hit the chords? That's right in the middle. So this little piece of the chord is the same as this little piece of the chord. In fact, that's what property 3 tells us. A perpendicular bisector of a chord goes through the center of the circle. So I'm going to draw the center of a circle, and I'm going to draw a chord. And if I bisect that chord, which in my picture would have to be halfway between 0 and 30, which is at 15. So if I bisect it and I put a little mark there at the 15, bisect, cut in half or into two congruent segments. So this segment congruent to this segment, and perpendicular. So notice again, I'm using the cheat way to make perpendicular by using my rectangular ruler. So drawing a line down there, now I'm going to extend my ruler so that I can complete that line to go all the way through my chord and maybe even into my circle. I can even extend that the other way. So perpendicular, I made the right angle. Bisector, I cut it in half. Of this chord has to go through the center of the circle, which means that segment will be a diameter or a radius, or any type of segment that's going to touch the center of the circle. How can we apply that? Let's take a look. The following circle, diameter BD, is perpendicular to chord AC at point E. So first thing, I saw a diameter. They talked about a diameter perpendicular to a chord. If the diameter is going to be perpendicular to a chord, we know it has to bisect the chord. And then applying a property we used earlier, if this segment is congruent to this segment, then this arc is congruent to this arc. Mark what we know. Part A, if CE equals 3, then what is AE? CE is 3, so AE also has to be 3. AE equals 3. We marked it congruent, so the rest is just filling in the blanks. Second, if the measure of arc AC is 100 degrees, so arc AC from here all the way to here, 100 degrees, then what is the measure of arc AB and the measure of arc BC? Well, if we know arc AB is congruent to arc BC and the whole way across is 100, then all we have to do is split up the 100 into two congruent parts. So each one is 50 degrees. Now look back at those 5 properties we just talked about, and you can write yourself a short summary to see if you can remember the specifics of each property. See you in class.